Welcome to Talking Supply Chain. In each episode, top supply chain industry professionals and the nation's top thought leaders join host Brian Strait and share their unique insights to help supply chain managers stay one step ahead of their competition. This is Talking Supply Chain. Hello, and welcome to this episode of Talking Supply Chain. I am your host, Brian Strait, and today we're going to talk about a little sporting event that many of you around the world are probably watching right now. Yes, I'm talking about the Olympics. So the Olympics may be winding down, but the medals won by the athletes will be memories for a lifetime. According to the International Olympic Committee requirements, gold medals are made of at least 92.5% silver, who knew, and about 6 grams of gold. There'll be about 1,000 gold, silver, and bronze medals handed out at this year's Olympics. But I think many people have the question, how are they made? What's that process like? Where does it begin? And how do all these medals get to Paris? Joining me today to shine some light on the process is Tessa Axsom, Director of CNC for Fictiv. Welcome, Tessa. It's nice to have you with us today.
Thanks, Brian. My name's Tessa Axsom, and I've been with Fictiv for about 2 years now, and I love it here. I'm a mechanical engineer by training, and I have a background in aerospace design, metallurgy, finishing, CNC machining, welding, brazing, and raw material production. So a little bit about, sorry, that was a mouthful. A little bit about Fictiv. We are a global manufacturing company, and we have the goal of simplifying sourcing for custom manufacturing, all the way from prototyping to production. I love my job at Fictiv because I actually believe in our motto of enabling innovators to create. And what we do is we break down the historic barriers that are in the traditional manufacturing process, and we bring your designs to life so you can get time back. And this is all accomplished through our really awesome global manufacturing network and our super sophisticated AI-powered technology platform that gives you instant design for manufacturability feedback. We have 4 regions in USA, Mexico, India, and China, and we deliver fast and high quality parts. And we also have 7 capabilities to handle your full BOM. And all of this has allowed us to deliver over 30 million parts for early stage startups and large enterprises alike.
Great. That's great. I mean, yes, a lot of information there for everybody on Fictiv and yourself, but great. I think people have need to know this information. As we kind of frame this conversation, though, I just want to be clear to audience, right? Fictiv, correct me if I'm wrong, but Fictiv was not involved in the design and manufacture of this year's medals, right?
Yes, that's correct. We were not involved in the design or manufacture of the medals. That is actually something that is selected by the Olympic Committee.
You do have expertise in this area, though, right? I mean, this is kind of what we're talking about today, is kind of this expertise, these specialty manufacturing processes.
Yes, I've been in manufacturing for over 10 years, and I have a lot of experience in product development from concept feasibility to prototyping, testing, and then production. I've done this as a design engineer, quality manager, metallurgist, and consultant. But as I said, the Olympic medal design manufacturing follows the standard product development process that's overseen by the Olympic Committee.
Yep. So I think that expertise, right, of what you guys have and what your expertise is what we want to tap into today. So while most of our listeners are not going to be making Olympic medals anytime soon, although if your company does, congratulations, that's a great honor. But they do have a lot of similar projects, and hopefully some of what we talk about today, they can learn and kind of incorporate some of the stuff into their own projects. And we're using the Olympics kind of as an example here. So to get started at the beginning here, can you talk about what goes into the process of designing an Olympic medal?
So it's actually more of an artistic process. So it actually varies with the hosting country. So for example, when the Olympic medals were handed out in Tokyo 4 years ago, those are actually a result of a design that was selected from submissions via a nationwide call to all professional designers and students. So the director of Japan Sign Design Association and Osaka Design Society was given the award for that because of his uniqueness. And then when it came to the design for the Paris 2024 Olympic medal, called the fashion capital of the world. The committee called on Louis Vuitton, Moet, Hennessy jewelry, and watchmaking designer Chamit. And so Chamit design director Clementine Monasat led the design, and that features a really cool item. So it's a piece of the Eiffel Tower itself. And the metal design, irregardless, is always approved by the organizing committee of the Olympics and Paralympics Games um, for whatever country they're in.
Yeah. Wonderful job with those names. I'm glad you were the one who had to say them and not me.
Oh, they're a mouthful.
So you mentioned that this year's medals include a piece of the Eiffel Tower, which is pretty unique. Um, that obviously is a specialty process in the manufacturing. So when something like that is incorporated, in this case, a piece of the Eiffel Tower, is that a difficult process to do to get it into the manufacturing process, especially with such a small little piece? And how would you go about kind of setting that up and accomplishing that to make it work?
So, yes, you are right. The Olympic medals for 2024 do contain pieces of the Eiffel Tower itself, which is pretty inventive. I feel like it's a nice way to incorporate the city's history. And I also find it interesting because the Eiffel Tower was originally constructed out of puddle iron, which is more commonly known as wrought iron. And as we all know, iron has a tendency to rust because of the highly, or because of its high affinity for oxidation. And this reaction occurs on the surface as rust. Um, and this is so significant that actually the Eiffel Tower must be stripped, coated with a rust preventative substance, and painted every 7 years. There are a lot of concerns that it will succumb to corrosion, although it has not yet. So for the 2024 Olympic medals, the thing that kind of struck me was the potential for corrosion via galvanic corrosion that occurs when you place two metals in contact. So think of this as kind of like how a battery works, and one of the metals is depleted over time and kind of breaks down, while the other one is fine. So that's a sacrificial metal. So when you place two metals in contact with each other, you actually get a voltage that's created due to an electrode potential difference,
Mhm.
which is known as a galvanic cell potential. And the difference between silver and iron is 0.124 volts, meaning that corrosion is likely. So basically, they need to really ensure that both of these metals are protected from contact with each other.
Yeah.
Um, and I'm sure that it'll be less of a concern because you need moisture, water to complete the galvanic reaction. And these metals will likely be stored in pristine conditions only.
So not like the Stanley Cup that the NHL teams have, and they throw them into oceans and things. Then
Uh,
the Olympics probably not doing that with their Olympics.
I would imagine not.
So, as I mentioned in the open, we kind of referenced this year's gold medals actually about 92% silver. So for those who win the gold, they're actually getting silver, right? I guess I don't know. Why would you make a decision like that? Is that kind of a cost concern? Is it a manufacturing challenge that makes it easier to go with silver as opposed to using gold?
Well, Brian, while gold has been on average about 59 times more expensive troy ounce per troy ounce
Yeah.
um, on over the last decade, I doubt it's a significant concern with all the Olympic sponsorship money.
Mhm.
So the original Olympic Games charter actually describes the first place medal as silver gilt, which wasn't really a term I knew before reading the charter, which is a good read if you want to fall asleep fast. Um, Gilded silver is actually silver part that's been plated with gold.
Okay.
And it's often used in jewelry. Like a lot of our gold jewelry is actually sterling silver with gold plating.
Mhm.
Um, and the Olympic Committee actually sets the requirements for the composition of the medal, as you said. And pure gold also, or most importantly, would not be practical because gold is actually really malleable and ductile. So that
Yeah.
means it's easily stretched or formed. And so it would also be difficult to machine because of this, and it wouldn't be very practical for like everyday use, right? Um, so gold jewelry actually has a lower purity if it's pure gold or silver that has been plated with gold, as I said. And so interestingly, this is also why Olympic medal recipients bite their medals. If you've ever wondered why they put them in their mouths and take a bite.
Yeah.
The gold is soft enough to make an indent on, proving that it's real pure gold.
Huh. Interesting. Interesting. I guess if I have even 6% gold in my hands, I'm pretty happy with that. So I'm sure all the Olympians are too. Um,
Sure.
for a project something like this, I mean, these medals have to be very precise, right? And they have to be delivered on time. I don't think that Simone Biles would be too happy if the organizers told her, "Hey, we're going to ship that Olympic gold medal for gymnastics to you in 4 to 6 weeks," right? So that's not unlike other special manufacturing process projects that companies deal with on a regular basis, right? There's timelines, there's things need to be done by a certain date. Um, and then such precision needs to be incorporated as well on the manufacturing side. So when doing a project like this, and maybe talk with the Olympic standpoint, but in general as well, how do you go about choosing a manufacturer? What kind of considerations do you need to be thinking about when making a decision on who to go with on these kind of projects?
So, if we consider like the triangle of manufacturing, um, selection requirements, you have cost, lead time, and quality.
Mhm.
So those are the three pillars that make up the triangle. And I would imagine that the Olympic Committee was utilizing those parameters um, whenever they selected their manufacturer. But what's actually really interesting is that manufacturing of each set of Olympic and Paralympic medals has always been the responsibility of the host city since the year 1896,
Huh.
when the medals were made in Paris. So we've made like the full circle. Um, and then, moreover, the manufacturing has traditionally been completed by each city's mint, which, if you don't know, is the manufacturer of coins in their region. So they're kind of experts in
Okay.
making discs of metal with, raised features, I guess you could say. And I'm not privy to the exact set of specifications a manufacturer must meet for being selected to produce Olympic medals, but I'd say they have to have the experience, manufacturing capabilities, and a lot of proven quality track record
Yeah.
and security. So, with all of these precious metals, there is a risk of theft and even perhaps a question of authenticity.
Yeah. So, I mean, those are all things that a typical manufacturer for any project you're doing must, you consider as well. Then, the capabilities of your manufacturing partners, track record,
Mhm.
things like that are all
IP
similar.
protection,
Yeah.
it's a different kind of security, but absolutely.
Yeah. So there is the manufacturing component of this. There is the design component of this, right? I mean, as you mentioned earlier, the designer of the metals, the manufacturing partner who did it, and just like a regular process, these two sides need to come together in some way. So, in this case, incorporating piece of the Eiffel Tower adds complexity to the manufacturing process. So, what is the collaboration like between the designers, the manufacturers, partners? I mean, is this a critical, not just for this, but any project? Is that process really critical that the manufacturing partner and the designers work together to make sure that the designer is not designing something that manufacturers can't do?
Right. So actually what kind of struck me here is I remember I was working in the aerospace industry and we would always be referred to as design engineers as
Mhm.
divas. And so it was like the manufacturing team would say that we had these, ridiculous requirements and we didn't need to put all that into the design. Like that's absurd.
Yeah,
So I'm reading about the Olympic medal design being done by this, extremely high profile famous company,
yeah,
a jewelry designer. And I'm like, oh my goodness, they must be seen as like the biggest divas.
yeah,
And so I imagine there was a considerable amount of collaboration between the designers and the manufacturing experts at the Paris Mint. Um, so typically during the design and prototyping phases, the manufacturing partners would be providing insight to the designers as to how feasible the design is to manufacture.
Mhm.
And so that ensures, like reliability, repeatability, and cost reduction to the designers. And certainly adding on the Eiffel Tower piece was kind of a complexity wrench thrown into the equation, right? So it actually had to be crusted in each metal and affix those six appendages, which had never been done this way, but it was a throwback to the design of the Eiffel Tower.
Yeah.
So, as a design engineer, it is often easy to prioritize fit and function of a part, right? Does it work as it was intended? Is it robust enough? Um, for most engineers, aesthetics are kind of an afterthought. I can say that when aesthetics are prioritized by a customer, though, the manufacturing becomes more complex because a lot of our processes aren't intended for purely visual aesthetic purposes.
Yeah.
So fine details and craftsmanship take time and expertise. And the Paris Mint was obviously an excellent choice for this project and because of their extensive experience in coin manufacturing. But I have it on good word that they had to modify their existing processes or add new processes altogether to achieve these complex design requirements.
Yeah. I remember, as you started that answer, I remember a friend of mine, and we used to ask him, "What do you do? What do you do?" And he never would tell us what he did. And then one day he told us, and he said, it's my job to take what the engineers send us and figure out what it is they put in it that they don't really need." Like,
Yep, that sounds familiar, Brian.
so I always thought
Oh,
that was funny. He always joked that it's like my job was to take it and make it actually makeable. That's what we did.
yeah.
So
It's like we want things that can fly and drive and roll, and
yeah,
the manufacturers are like, "Whoa, that's not even possible."
yeah.
So,
So, you know, many organizations these days are facing sustainability and ethical sourcing requirements, whether they're local governments, federal governments, even just internally, their own processes. And I know the Paris Organizing Committee was no different. They had some of these rules in place. Can you talk a little bit about what they decided about this year's medals in terms of sourcing requirements?
yes. So, of course, we have the sustainability feature with the 18 grams
Mhm.
from the Eiffel Tower iron inserted at the heart. And so that actually has a different purpose. So it's actually there also to highlight the concept of the circular economy. And that's an economic system that's based on the reuse or regeneration of materials. And then if we consider the gold and silver as well, used for the metals, those were both made of 100% recycled material that was also certified by the Responsible Jewelry Council, which, given the name, I'm guessing has an extremely high focus on sustainability.
Yeah.
And then the bronze metals themselves are made of an alloy of copper, tin, and zinc, which was made from reused metal scraps from other productions at the Paris Mint. Pretty cool.
Huh. Neat. So a lot of it is, I mean, the Paris Olympics have been a lot about sustainability. We've heard a lot about that this year, for
hmm
those who are paying attention. So they carried all that through with their medals as well. Um, can you kind of walk us through the actual production of the medals? Can you talk about how they maybe have made the medal this year?
Sure. So, as I've said, the Monet de Paris or the Paris Mint, I hope I pronounced that correctly,
Better,
it
better,
was
better than I would do, I'm sure.
it was actually tasked with making the Paris 2024 medals. So, what you have, Brian, is you need to melt the metals first. So the silver or brass is molten and it's poured into a really precise mold to create a disc shape. Perhaps some of the contours of the design are built into the mold. Not sure exactly how that looks, but then from the Paris Mint, the metal discs are stamped, or I'm sorry, the Paris Mint. The metal discs
Yes.
are stamped or embossed by a hydraulic press with a die on it to create the desired contours and shape that the artist had set forth. And then, although this information wasn't available on this site, it would be reasonable to assume that all or most of the metals are pretty fine tuned or further engraved by an expert in metalworking.
Mhm.
So, what happens next is the finishing process. And this is very similar for a lot of metal parts for any industry. So, the bronze and silver metals are both polished, and the silver metals go on to be electroplated. So, you get that pure gold coating for the gold parts
Yeah.
or the gold metals, sorry. And so, electroplating, if you don't know, is an electrochemical process that allows metal to be deposited on the surface of a part. Um, the silver metals are just done there. They're provided with a protective coating. Um, and then sort of the bronze ones. And then the iron pieces from the Eiffel Tower are encrusted on the front surface of the metals and affixed with thick appendages. And I believe that would be likely a soldering type process. And then, they're shipped.
Yeah. Very common process, right? I mean, it's not unique
Mhm.
process per se. This is very common in manufacturing to do it this way. What kind of timeline does it take to design these, to do this from the design to the manufacture process? I mean, are we talking months, years? What are we talking about to actually go through this whole project?
I would estimate the process to take at least a year from the initial design and conceptualization to the shipping of the finished product. But I would say it's likely that the ideation and research was started several months before then, and even as early as when Paris was selected to host the 2024 Olympic Games, because the design was released in February of 2024.
Yeah.
And what's really interesting is that one Paris Olympic medal takes about 10 hours of hands-on time to make.
Wow.
And, a mint is a smooth operation with well-defined process and policies. So I'm sure that in this case, they were able to streamline the process a bit.
Yeah. The I want to ask about this because I think this relates to manufacturing in general, right? I mean, we always talk about quality control is a big part of manufacturing. For the athletes that win the medals, regardless of whether it's gold, silver, or bronze, right? This is expected to last a lifetime, and I would guess in many cases they're going to hand these medals down to their descendants, right? I mean, so we could be talking 100 years plus that these medals exist. So when you talk about quality control, what's the quality control process for a project like this where you're thinking about something that has to last long periods of time? And maybe in our traditional manufacturing world, we're not trying to build something for 200 years, but what kind of quality control process would you have for a project like this where you're expecting long life out of what you're making?
Right. So when I think of the Olympic medals, I think of, white cotton gloves and clean rooms. And,
Yeah.
it's very, very precise. So each medal is definitely heavily scrutinized for everything from aesthetics to composition to environmental resistance. So I believe that the quality control process for each metal would be subjected to all things like visual inspection with microscopes. They're each weighed to make sure that they achieve the end desired weight. You don't want one person to have a medal and look over at their friend and pick up their medal and be like, oh my gosh, yours weighs way more than mine. Um, and then the metals are heavily scrutinized for composition or purity. And so an XRF or X-ray fluorescence actually accomplishes that. And then I believe there's some process conformity testing and environmental testing, whether it's destructive or non-destructive.
Yep. So, I mean, basically, I just want to make sure that the medal that I've won, if Olympics, if you're listening, please hand me a medal. I would love to have one. Um, Get it handed down to my kids, and I can claim, and 150 years from now, my family can claim that I won this medal and whatnot. But we've spent a lot of time talking about medals, the Olympic medals here. But the idea of this podcast was that this is a specialty project. That's something you guys at Fictiv are very familiar with. So I want to ask you a more of a general question for the businesses listening out there. Would that dive into these types of projects? It might be a one-off project or a limited run production project that they're doing, maybe a pilot project, et cetera. And it may not be for the Olympics, right? But to their customer, it is the Olympics. So can you offer some final advice on how to approach these types of projects? What should a company consider before getting started? How do they go about that process?
Yeah, so I have been in your shoes before if you're listening and you're a design engineer. So it's often a little bit overwhelming to handle one project of this caliber, let alone you're probably handling more than one.
Mhm.
So my first tip is to, stay organized. Always try and utilize planning tools like Gantt charts or just simple Excel spreadsheets, honestly. I know it's a pain and you don't think that you need it up front, but you're going to need it. Um, Also, if you're designing something with high aesthetic requirements like the Olympic medal, always consult with artists or graphic designers. Like, don't try to take that on yourself. It's really complex and it's okay to ask for help, is what I'm saying.
Yep.
Um, so with the token of asking for help, also try to seek advice of the experts in your area that you need parts manufactured in. So at Fictiv, for example, we have experts in aerospace and automotive and the medical industries and more. And, just like the Olympic medals are typically manufactured by a local mint, find someone who is already experienced in the manufacturing in your industry and use them as a resource. Let them look at your designs, let them redline your prints, let them
Yep.
give you all the feedback. I always loved it when people reviewed my designs and would give me feedback. So try to be humble and accept that well.
Yeah. So while you may be inventing the wheel, you don't need to invent the manufacturer of the wheel,
Sure.
right? People have already done that.
Yes.
So take advantage of that. We are out of time, but Tessa, thank you so much. If listeners want to learn more, how can they get in touch with either you or Fictiv?
Yeah, so you can check out our capabilities and get in contact with us at fictiv.com. That's Fictiv. Or you can even feel free to send me an email. And my email address is tessa.axsom@fictiv.com. Or you can catch me on LinkedIn.
Great. Thank you so much for your time. I want to thank Tessa Axsom for joining me today and all of you that took a few minutes out of your day to listen to us. I greatly appreciate it. A new episode of Talking Supply Chain comes out each Thursday on scmr.com or wherever you get your podcasts, so be sure to subscribe so you never miss an episode. Until next time, this is Brian Straight, and you've been listening to Talking Supply Chain. Talking Supply Chain is produced by Supply Chain Management Review and Peerless Media. You can find it on scmr.com, supplychain247.com, iTunes, Google Podcasts, or wherever you find your podcasts. For more information on this topic or to sign up for our weekly newsletter, a print or a digital subscription to our publication, visit scmr.com. We hope you will join us for our next episode. For Supply Chain Management Review, I'm Brian Straight, and thank you for listening.